In this video, we're going to look at simultaneous equations. When we're solving equations simultaneously, we're looking to find the values of the unknowns that satisfy all of the equations involved. If we take two linear equations, let's say we've got the first one, and that's x plus y, and we'll let that be equal to 8. A second equation, let's say we've got 2x minus y is equal to 1. There are infinitely many points that satisfy this equation and infinitely many points that satisfy this equation. What we're looking to do is find now a value of x and a value of y that satisfy both. In this particular case, that's only going to be one value of x and one value of y. So let's go ahead and look at this graphically. So if we did x plus y is equal to 8, that's just a straight line, and we could show that looking something like so. And that would just continue. If we looked at this line right here, we would have something like so. So let's just go ahead and put that on, and that one would look something like that. So let's just straighten this out a touch. There we go. So we got two straight lines. So let's just go ahead and just label these up and pick some points. So this is x plus y is equal to 8. So there's a point just here, and this is 8, 0. So when x is equal to 8, y is equal to 0, that satisfies it. If we look at this point right here, now 0, 8, if x is 0, y is 8, that satisfies it. And we can see that there are going to be infinitely many points on that line. In the same way, if we chose this one right here, this is going to be now 0, minus 1. That satisfies the equation now 2x minus y is equal to 1. We can see in this particular case, the point of intersection of these two lines are now the values of x and y that satisfy both x plus y is equal to 8 and 2x minus y is equal to 1. We can now find this a number of different ways. Generally, graphing is not the best way, as it's really quite inaccurate at times. In the video, we're going to look at a range of different techniques where we've got either two linear equations, one linear and one non-linear equation, or two non-linear equations. When we're solving equations simultaneously, if we've got two unknowns, we need at least two equations to solve for them. So I can't solve for x and y in this particular case if I have one equation. That's the fundamental theorem of algebra. If I've got, for example, now x minus 1 is equal to 4, then we can see that x is equal to 5. I only need this one equation to solve for one unknown. If we got two unknowns, x and y, I need at least two equations. If I had x, y and z, I would need at least three equations. So how could we solve this? Well, there are a couple of techniques to use to solve linear equations. And when we're talking about linear, we're talking about now x to the first and y to the first. So these are just two straight lines. The first method you've probably met before is elimination. With elimination, we either make the x's the same or the y's the same. Once they are, we either add if the signs are different, or we subtract now if the signs are the same. So let's look at this particular case, and this should be just simple revision. So let's go ahead and look at this. Now x plus y is equal to 8 and 2x minus y is equal to 1. We can see that the coefficient on the y term in both cases is 1. Therefore, now that's the same. So we don't need to make any alterations. The sign in front of that number 1 is going to be different. So all I'm going to do in my working is put now 1 plus 2. So what I'm going to do is eliminate y by adding these together. So if I add them, x plus 2x is 3x. If I have plus 1y and then I add to it minus 1y, that disappears. And then I've got now 8 plus 1, which is 9. So we've got now 3x is equal to 9, dividing both sides by 3, x is equal to 3. At this stage, I'm going to sub it back into equation 1. Equation 1's easier. We know that x is 3. 3 plus y is equal to 8. So we can see that y is equal to 5 by subtracting now the 3 from both sides. So this gives us our point, and that is 3, 5. Whenever you're solving for simultaneous equations, do check that this point satisfies both. We know it satisfies the first. Let's just check. 2 lots of 3 is 6, minus 5 is 1, so it holds true. So we can see in this particular case, we've got now one point of intersection. If we had, for example, a quadratic, so a parabola and a straight line, We might have 1 point, so it might be touching, it might be a tangent. We might have 2 points, or we might have 0 points. So let's look at a quick example of that. So let's just draw a few different scenarios where we might have different outcomes. So let's just put up some coordinate axes here, and we'll put another one just here. So if we had a parabola, so a quadratic and a linear, we might have something that looks like this. So my quadratic might be just here. Let's draw a few on here. Might have something that looks like that. Might have something that looks like that. So we might have now, in one particular case, we might have 2 points of intersection. So we can see now that the line passes through the quadratic in 2 places. And we're going to shortly look at the methods in which we've used to solve this. We might have 1 point of intersection, and that would be called a tangent. So that would just touch. And in previous videos, we've looked at the discriminant, and we'll see how this helps us as well. Or we might have something, for example, now that looks like that. So we've got no points of intersection. So here are some of the particular examples of this. Now, in terms of our straight lines here, if we had now x plus, let's put on number 3, let's put this one right here, let's put a third equation. Let's say we've got now x plus y is equal to 6, and we were asked to solve now for 1 and 3. So let's bring that in. Let's put another line on here. Let's go ahead and do that. Let's put that there. Now x plus y is equal to 6 will look something like so. We can see now that the gradient of 1 and 3 are the same, so they're going to be parallel. They're never going to meet, so there aren't going to be any solutions to that. So if you're thinking, well, I can't manage to manipulate this to get a solution, just have a think, is this logical? Is this working? Why is it not working? And we can see now it's because the gradient. And again, if you wanted to rearrange this, y is equal to minus x plus 8, and y is equal to minus x plus 6. And you can see they're never going to touch. Therefore, there's no point that satisfies both of those. Okay, let's now look at an alternative technique to solve these equations. So I'm going to take 1 and 2 again. Now with 1 and 2, these are linear equations. And often students like to use the method of elimination. So what I've done here, I've used elimination by, essentially, I didn't make them. They were already, the coefficient on the y term was the same, so I added them together. An alternative is as follows. We could write now that 1, the first equation, x plus y is equal now to 8. And we could write the second equation now, so let's write number 2, and we've got 2x minus y is equal to 1. This time I'm going to use substitution. Now, when we're talking about substitution, what I'm going to do is either take equation 1 or equation 2 and make x or y the subject. The advantage of this is that we can use this method for non-linear equations. We can't use this method of making the coefficient the same with one linear and one non-linear. So this is a technique that you're going to need to use. What I'm going to do is just rewrite equation 2. I'm going to add y to both sides and subtract 1. So what we've got then is y is equal to 2x minus 1. Now at this stage I've expressed y in terms of x. If I substitute this into equation 1, I've got x plus y. Well, now we've got this value of 2x minus 1, and that's going to be equal to 8. So by rearranging now equation number 2, I've made a substitution to eliminate y. So all of this now is in terms of x. So we've got 3x minus 1 is equal to 8. Add 1 to both sides, 3x is equal to 9. X is equal to 3, and then of course we can go ahead and sub in to find in either one of these, so we could put it back into here. I didn't need to do that. I could have gone another way and I could have made x the subject. So in the top one I could have said that x was 8 minus y and subbed it in. On here I wouldn't really want to make 2x the subject as it would be a bit messy. So this is the method of elimination for linear simultaneous equations. This is the method of substitution. What we're going to do is work through a few of these, and again it might be straightforward revision, and then move on to some where we have a linear and non-linear equation. Okay, so what I'm going to do is use both techniques to begin with. So let's start off, we'll say that equation 1, and always label these up, you generally won't be given 1 and 2, x plus y is equal to 6, and then number 2 we'll go for x minus y is equal now to 2. So I can see that the coefficient on both the x's are the same and the coefficient on the y's are the same. At this stage, I could graph them. It would be really pointless in doing so, but we could if we wanted. We could graph them. I see it to be massively time consuming, but it does give us some idea of what's going on. So what could we do? Well, I've got 1 here. Let's just put a 1 here. I've got 1 here, and I've got 1 here and 1 here. So what I could do now, because this is a positive one and this is a positive one, I could subtract the equations. So I could do 1 minus 2. If I do that, x minus x is going to give me 0. I've got y minus minus y, which is going to give me 2y. And then I've got 6 minus 2, which is going to give me 4. So that tells me that y would be equal to 2. All I need to do is sub it back in here, or in this one, and I could put that back into equation 1, and I'd have x plus 2 is equal to 6, so x would be equal to 4. Just check that that works in the second equation, so quite clearly it does. We got 4 minus 2, which is 2. Alternatively, what I could have done is added these equations together. So if I do 1 plus 2, adding these together, I'm going to end up now by having 2x, so let's put that, 2x, y plus minus y will disappear, and then we'll end up now with 8. Dividing both sides by 2, x is going to be 4, and then I can sub it into either one now to find y. So that's the method of elimination. If I'd done this now and used the method of substitution, so let's start again, method of substitution, x plus y is equal to 6, and then equation 2, x, and I'm going to rewrite this now as x minus 2 is equal to y. So I've added y to both sides and subtracted 2, and at this stage I can substitute in. So equation 1 will become x plus y, which is x minus 2, and that's equal to 6. 2x minus 2 is equal to 6. 2x is equal to 8. And then we can see that x would be equal to 4. And again, you could just go ahead and sub that back in and see that y is equal to 2 and check that it satisfies both. I think this is a lot quicker, but this is a technique that you will need to be comfortable with if you are going ahead and solving one linear and one non-linear. So that might be a line in a quadratic, it might be a line in a circle, it might be now a reciprocal graph and a line. It's just something that you need to get the practice on. Okay, so let's move through a couple of these. Let's go for another one. Let's say we've got now x plus 3y is equal to 8. And then we've got x minus, and we'll go for x minus 2y is equal to 3. What I'm going to do now, I can see that the coefficient on the x term here is 1. We've got 1. They're the same. The signs are the same as they're both positive. So all I'm going to do is subtract them. So I'm going to do 1 minus 2. Now, if it works in your favour, don't be worried or don't be afraid just to turn them the other way around. Just have this as equation 1 and this as equation 2. It really doesn't matter. So subtracting away, I'm going to get 0. 3y minus 2y is going to give me 5y. 8 minus 3 is 5. 5y is 5. Y is 1. And then all we need to do is sub that back in. So if we put that in equation 1, showing our working, x plus now 3 lots of 1 is equal to 8. So we can see that x is going to be equal to 8 minus 3, which is 5. Does that hold true for the second one? Well, if we put it in, we can see now that 5 minus 2 lots of 1 is 3, so it does work. Again, with this one, if you wanted, you could use the method of substitution. So if we just rewrite equation 2, we could write that x is equal to 2y plus 3. So I've made x the subject on this one, and then we can just rewrite equation 1. X plus 3y is equal now to 8, and then we can go ahead and solve. An alternative would, in fact, be to write equation number 1 as x is equal to 8y minus 3. 3y minus 8. 8 minus 3y. That looks a bit better. And then what we can do at this stage, let's just put this on. So this is going to be 8 minus 3y. So what I've done is just made x the subject in both. When you come on to a quadratic and a linear, this is quite helpful because if we've got x is equal to something and then x is equal to something else, those two things are equal. And at this stage, we could just say that 2y plus 3 is equal to 8 minus 3y. And we have our equation in terms of y. That is a long-winded way, and it's not too dissimilar to what I've done here, but we've made x the subject in both. So for example, now if I had, let's say I've got a quadratic, and I've got a quadratic y is equal to x squared minus x minus 6, and y is equal to, so this is a quadratic equation, this is a linear, y is equal now to, let's say we've got 2x minus 1. What we could say, if y is equal to this quantity and y is equal to this quantity, then they are equal. So we could just write 2x minus 1 is equal to x squared minus x minus 6, quadratic equation in x squared minus 3x minus 5 is equal to 0, and go ahead and see if there are any solutions to that equation. So you can see by making y, we've essentially eliminated it by making the subject. And again, we'll look at that as we go. So different methods, and it's fairly straightforward and probably just a bit of revision. Okay, let's do another one. Let's do x minus 6y minus 1 is equal to 0. And let's say we've got, now let's go for another one. Let's go for 3x plus 2y is equal to 13. Let's call this one equation 1. Let's call this one equation 2. Now, equation 1 you might want to rewrite. You might want to add 1 to both sides. So you might want to write it as x minus 6y is equal to 1. You might see that that's slightly easier to work with. Not necessarily, but you might do. Now, at this point, if we wanted to use the method of elimination, we need to make the coefficient on either the x or the y the same. We got 3x and x, so they're not the same, and we got 2y and 6y, which are not the same. So if I consider what I could do here, I could multiply this equation now by 3. That would make now the x values the same, or I could multiply this equation by 3, and that would make the y's the same. So as you can see, I've got a bit of choice. In the same way, for example, if we had, let's say we got 2x plus 4y is equal to 9, and then we've got now, let's say we've got 3x plus 5y is equal to 13. I'm not sure, you know, what they'll solve as, but in this one, what we could do is make the x's the same. If I did that, I'd need to multiply the top one now by 3 and the bottom one by 2. That would give me 6 as a coefficient on the x. Or I could multiply the top one by 5 and multiply the bottom one by 4 to put the y's the same as 20y. So it's entirely up to you at this stage. Try not to make your numbers too crazy, as it can become a bit of a nightmare. What I'm going to do is multiply this bottom one here, which is going to be equation 1, and I'm going to multiply that by 3. So now equation 2 is just 3x plus 2y is equal to 13, and then equation 1, which I've written like so, we've got 3x minus 18y is equal to 3. This is often a bit of an error students make. They don't multiply through by 3 on each term. Often they leave that there. So we can see we've got plus 3x. These are the same, so we can subtract down. So it's 2 minus 1. If I do that, I've got 2y minus 18y, which is 20y. And then now I've got 10 as 13 minus 3. So we can see now that y is equal to 10 over 20, which is 1/2. And then we can sub that back in. Now at this stage, we don't have to sub it back into either of these. You could do if you wanted. Let's put that back in. Or we could just put it back into these. I think we're just going to put that back into number 1 and write that as x minus 6 lots of 1/2 is equal to 1. X minus 3 is equal to 1. So x is going to be equal to 4. Do check that that value and that value satisfy the other equation. So if we sub in 1/2, that gives me 1. If I sub in 4, that gives me 12. 12 plus 1 is 13. So we can see that holds true. Okay, let's do one last linear and linear. Let's say we've got x over 3 minus y over, let's go for y over 4 is equal to 0. We'll call that one equation 1. Let's go for now equation 2, and let's say we've got x over 2 plus, let's go for 3y over 10, and that's going to be equal to, let's go for 27 over 5. Okay, what I'm going to do is just consider each equation in turn. I'm going to multiply through the equation equation 1 to begin with by the lowest common multiple. So I've got 3 in the denominator of one of the fractions, 4 in the other, so the lowest common multiple is going to be 12. So if I multiply this one by 12, I can rewrite this as equation 1. That will be 4x minus 3y is equal to 0. So now I've got integer values, whole number values. If I now look at number 2, I'm going to multiply that by the lowest common multiple. The lowest common multiple of 2, 10 and 5 is 10. So if I do that, I'm going to get 5x, and then I'm going to get plus 3y, and that's going to be equal now to 54. So I've got these simultaneous equations to solve, and this is what we're dealing with. At this stage, I can see, conveniently, I've got minus 3y plus 3y. These values are the same, the signs are different, so I'm going to use the method of elimination to just add these together. So we can say 1 plus 2, we're going to have 9x, and that's going to be equal to 54. Divide both sides by 9, x is 6, and now we can sub this back in. So we've got now 4 lots of 6 will be equal now to 3y, just adding 3y to both sides. 24 is equal to 3y, so y is going to be equal to 8. So do check that in that one. 5 lots of 6 is 30, plus 3 lots of 8 is 24, and that gives 54. So we've just used some basic work with fractions to rewrite those. Now, at this stage, what I could have done is rewritten this one and done a bit of substitution. So I could have said that 3y is equal to 4x. Let's put 4x. So y is going to be equal to 4x over 3. And now substituted that in here. Okay, so I could have eliminated now y. So this is now going into, so this is equation 1 going into equation 2. 5x plus 3 lots of 4x over 3 is going to be equal to 54. I've eliminated y by making a substitution. We've got 5x plus, the 3's are going to cancel, 4x is equal to 54, 9x is equal to 54, and we can see that x is going to be 55 over 9, which is 6. And at this stage, we can simply plug it back in to find y. So 4/3 of 6 is 24 over 3, which is going to give me 8. So that works that way. And do, again, check they satisfy the equations. So just yet another example of 2 fairly straightforward linear equations once you've got your head around the basics of writing these as integer values. Okay, let's now move on to a linear and a non-linear equation. Let's start off with y is equal to x squared and y is equal to x plus 6. So what I've got here now, if I wanted to graph this, let's have some understanding of what we've got. This is a quadratic, and when I'm talking about linear, this is not a linear equation as we've got a squared term. So if we had now y is equal to x plus 4, that's linear. This is non-linear as it's quadratic. Y is equal to x squared looks something like so. So we'll come round and it'll do that. That's a parabola. Y is equal to x plus 6. Let's go ahead and do that. X plus 6 is a straight line, gradient 1, passing through the point now. And again, however accurate you want to think this is going to be, it's going to go through this point right here. So when x is going to be equal to 0, y is going to be 6. So that's what we got. Here's the origin. We've got 0, 0. We've got y is equal to x squared, and we've got y is equal to x plus 6. Now we can see that we're going to have 2 points of intersection just here. The way in which we can solve this is if y is equal to x squared and y is equal to x plus 6, we can say, and just labelling these up, equation 1 and equation 2, therefore we can say that x squared is equal to x plus 6. We can rearrange, this is a quadratic, x squared minus x minus 6 is equal to 0. This is in the form ax squared plus bx plus c is equal to 0, and we can factor that. So we've got x minus 3, x plus 2 is equal to 0, and we can see that now x will be equal to 3 or x will be equal to minus 2. So we can see that the x coordinate here corresponds to the minus 2, and this one corresponds to the positive 3. Now, at this stage, some students think they've done it, they've solved it. All we've done here is found the x-coordinate. At this stage, we find the value of the y-coordinate by subbing this in to the linear equation. The linear equation in this particular case is the x plus 6. Don't go ahead and chuck it into the quadratic. Yes, in this particular case it's easy, but often if you have, for example, y, let's say we've got y is equal to 1/2 x squared minus 3x minus 7, and y is equal to x plus 2, and you have a value of x, quite clearly it's easier to chuck it into the linear. So let's go ahead and now start with x is equal to 3. So if x is equal to 3, showing our working, we can simply put now y is equal to 3 plus now 6. So this point is going to be 3, 9. So for solutions, we can write x is equal to 3, y is equal to 9. And if it asks for the coordinates, we would just put 3, 9. If we look now at this one, x is equal to minus 2, so y is going to be equal to minus 2 plus the 6. So we can see now that this point right here is going to be, what's that going to be, minus 2 comma 4. So x is equal to minus 2, and then y is going to be equal to positive 4. All the coordinates are minus 2 comma 4. So we've gone ahead and solved this, and this is a technique that you're going to need to use when we come on to things like integration, if we're finding the area trapped between the curve and the line. And a quick sketch shows us that. Okay, let's now consider the following. Let's say that equation number 2 was in fact now y is equal to x minus, and let's go for x minus 10. Now x minus 10 is going to look something like so. So let's now do that. Let's do that. So what we've got then is equation 1, y is equal to x squared, and y is equal to, so let's put that as equation 2, y is equal to, what have I chosen, x minus 10. Now, we would set these equal, and without the graphical representation, you're thinking, well, I kind of get an idea that this isn't going to work. So if y is equal to x squared and y is equal to x minus 10, therefore what we can say at this stage is x squared is equal to x minus 10. So we could say x squared minus x plus 10 is equal to 0. That's a quadratic in the form ax squared plus bx plus c is equal to 0. And you could look at trying to solve that. An alternative would just be to look at it and say, well, b squared minus 4ac. Now, if this is less than 0, then we're going to have no real roots. And we've looked at the discriminant in a previous video. So we've got a is equal to 1, we've got b is going to be equal to minus 1, and c is going to be equal to 10. So b squared, that's minus 1 squared, minus 4 lots of a multiplied by c is going to give us 1 minus 40, which is going to be equal to minus 39. Therefore, no real roots. So we've got no real roots. And that's an example of that. Now, we might have a scenario where we have one point of intersection. So we might get a point now here, let's go ahead, and we would have a repeated root. So that would be a tangent, for example, and we could, I mean, that's not a very accurate drawing, but we'll see in some cases that you'll see that you get a repeated root, or b squared minus 4ac is equal to 0. And that just tells us that it's going to be a tangent. Okay, let's move on and look at an example of another linear and non-linear equation. So let's go for x squared. So x squared plus y squared is equal to 20. Now, this is a circle, and I'll call this one equation 1. And then we've got now, let's take equation 2. We've got 2y minus x is equal to 0, and that's a line. So what we've got is the following. Let's just draw a quick sketch. So this is a circle. You should have met the basic equation of the circle before. X squared plus y squared is equal to r squared, and this just gives us now a circle. We've got centre 0, 0, and the radius of the square root of 20. So let's go ahead and do that. So let's do that and put that on. So that's what we've got now, and we've got this point right here. So this is going to be now root 20 comma 0. This is going to be 0 comma root 20. This is going to be minus root 20 comma 0, and this is going to be 0 comma minus root 20. Now, let's just look at this right here. What I'm going to do with this particular equation, I'm just going to rewrite it now and say that number 2, x is equal to 2y. Now, to begin with, you might want to think, well, I don't like that to think about drawing a line, or you could write that 1/2 x is equal to y. Now, that's just a straight line. So if we look at this now, what we're going to have is a straight line through the origin, gradient of a half, And we can see now, if I label this up, y is equal to 1/2 x. So let's put this on. And generally you would put now 2y minus x is equal to 0. We can see we can have 2 points of intersection. So let's go back here, and all I'm going to do is write equation 1. So we've got x squared plus y squared is equal to 20. We've rewritten equation 2, and we've said that x is equal to 2y. What I'm now going to do is sub this in. So I'm going to put it in to number 1, and I'm going to have 2y, which I'm going to square. That is x, plus y squared is going to be equal now to 20. So at this stage now, squaring this, I'm going to have 4y squared plus y squared is equal to 20. We've got 5y squared is equal to 20. Dividing both sides by 5, y squared is equal to 4. So we've got now y will be equal to plus or minus 2. So we can see now that the y coordinate is going to be plus or minus 2. So this now is going to be some value of x, and then we're going to have positive 2, and some value of x, and then we're going to have minus 2. At this stage now, we take the linear equation. It's a lot easier to put it through the linear equation. So what we know then, let's just put this in, y is going to be equal to 1/2 x. Or, if you like, you could put x is equal to 2y, and it's entirely up to you. You could choose any one of these. X is equal to 2y. So we can say when y is equal to 2, what we're going to have then is x is going to be equal to 2 lots of 2. So we're going to have x is equal to 4. And that gives us this point right here. So that's going to be now 4, 2. So we've got now the point, and let's put here, we've got 4, 2. If you're asked for the coordinates, that gives us now the coordinates. We can say now when, let's put this in, when y is equal to minus 2, because we've got plus or minus 2, we can say now that x will be equal to 2 lots of minus 2. So we've got x will be equal to minus 4. So we've got the points now minus 4, minus 2. And that's going to be this point down here. So that's that one just here. So we've got minus 4, minus 2. And we can see these 2 points of intersection. And again, a rough diagram has helped me out on that. And as you get more confident plotting these, it should be fairly straightforward. Admittedly, these have been quite easy. Sometimes it becomes a complete mess. But as long as you follow that technique, it should be perfectly fine. Now, at this stage, you could have just gone ahead like so. And you could have said, well, y is equal to 1/2 x, and sub that in. You could have said, now, equation 1 becomes x squared plus now 1/2 x, which we're going to square, and that's equal to 20. So instead of eliminating the x's, I'm eliminating the y's. So I've got x squared plus 1/4 x squared is equal to 20. If I now multiply it through by the 4, I'm going to have 4x squared. I'm going to have plus x squared is equal to 80. I can see I've got 5x squared is equal to 80. Dividing both sides now by 5, x squared is equal to 16. X is equal to plus or minus the square root of 16, which is 4. Then I can sub back into my linear to find y. As you can see, though, it was easier going this way, but we can go any way we like. And some particular equations will lend themselves better in a certain form than others. It's entirely up to you, really. Just make it work for you. Okay, so that's an example of a circle, which is non-linear. Quite clearly it's non-linear. As you can see, it's a circle and a linear equation. Let's go ahead and look at an example of another linear and non-linear. Okay, this time let's write these up. So let's say equation 1, we've got x, y is equal to 4, and we've got a second equation, let's call this equation 2, and let's say we've got y is equal to 2x plus 2. Now this one right here, I'm just going to rewrite equation 1. What I'm going to do is I can either make x the subject or y the subject. I'm going to write y is equal to 4 over x, and I'm just going to rewrite number 2 as it is. Y is equal now to 2x plus 2. Now, at this stage, I've got a few different choices. What I'm going to do is just graph this up and give you some idea of what this looks like. We've seen y is equal to 1 over x. You've probably met that lower down the school. If not, you've probably seen it in your studies before. Let's just grab a white pen. So we've got y is equal to 1 over x. That's the reciprocal graph. If I've got 4 over x, it's not too different. It's just a scale factor stretch of 4. It's going to look something like that. It's not brilliant, but it gives us some idea, and it'll go somewhere around like so. Now, this is 2x plus 2, which is a straight line. 2x plus 2 is going to have a gradient of 2 and cut like so. So we can see that we got these 2 points of intersection. So again, we're going to have two solutions. One is going to be there, and one is going to be here. So how do we go ahead and solve this? Well, I can see now one particular method I could use is, well, y is equal to 4 over x, and y is equal to 2x plus 2. Therefore, what I can say at this stage now is 4 over x must be equal to 2x plus 2. Now, this is what I would call a hidden quadratic. I'm going to multiply both sides of the equation now by the x. So we've got 4 is equal to 2x squared plus 2x. Rearranging this, 0 is going to be equal to 2x squared plus 2x, and then we're going to have minus 4. We can divide the equation by 2, so we've got x squared plus x minus 2 is equal to 0. That's going to factor. We've got now on here, what's that going to give me? X plus 2, and then we're going to have now x minus 1 is equal to 0. So we can see that x will be equal to minus 2, or x will be equal to 1. So we can see that the x-coordinate just here, minus 2, corresponds to this point of intersection, and then the positive 1 corresponds to that one. Now, at this stage, you can put it into either of these. I think it's easier putting it into this one right here. So if we put in now x into the non-linear, generally, I mean, as I say, it's entirely up to you. You can see there's no real difference in which one you use right now. So at this stage, we can say now when x is equal to minus 2, y is going to be equal to, you can put it in the linear one if you want, y is going to be 2 lots of minus 2 plus 2, so we've got y is going to be equal to minus 2, and again you can put it through there, so that's going to be minus 2. And then we can say now that the coordinates of that point are minus 2 comma minus 2, and we can say now when x is equal to positive 1, we've got now y will be equal to 2 lots of 1 plus 2, and we can say y is going to be equal to 4. So the coordinates of that one are 1 comma 4. Of course, you could have put 1 in here, and you would have just had 4 over 1. So that gives us 1 comma 4. So we found those points of intersection. So I've set the equations equal and gone ahead doing them. As you can see, the method of elimination by subtracting downwards is not going to work, as we've got a product, we've got a multiple of x and y, and you're not going to eliminate in that way. So we need to make one of them a subject. I could have quite clearly written x is equal to 4 over y, substituted that in, and gone from there. It's entirely up to you. You're just making one of them the subject and substituting it in to the second equation or setting them equal. Okay, let's have a go at something a little messy. Let's see how good our algebra is. Let's say we've got equation 1, and let's go for x squared minus xy. So we've got a product. Product means multiple, or multiply I should say. So we're multiplying x by y, and we'll say that that's going to be equal to, let's go for minus 11, and let's take a second equation. Let's go for 2x. 2x plus y, and we'll let that be equal to 1. So we've got two equations, and that first one's certainly not linear. As you can see, that's a complete mess. So we've got x squared, we've got y squared, we've got an x times by y. So quite clearly what we want to do is consider making either x a subject here or y. I'm going to make y the subject because I really don't want something divided by 2. So all I'm going to say is y is going to be equal to 1 minus 2x. So I've rewritten equation 2 to make y the subject. Therefore, equation 1, we're going to have now x squared minus x multiplied by y. Well, y is now 1 minus 2x. Then we're going to get minus, and we're going to have now this value of 1 minus 2x. And I don't need the double brackets here. I'm just kind of sectioning that off just to give us a little sort of idea of what's going on here, just so I don't mess a negative up. So let's go ahead and do this. So we're going to have x squared minus x, then we're going to have plus 2x squared, then we'll have now minus, and if I expand this bracket, I'm going to have 1 minus 4x plus 4x squared, and that's going to be equal to minus 11. So what we're going to have here, we've got now x squared plus 2x squared, and then we're going to have minus 4x squared. So that's going to give me what? Minus x squared. Let's put that there. Minus x squared. I've got minus x plus 4x, which is going to, what's that going to give me in total? Let's just check that. So that's, what's that going to give me? Plus 3x, so minus x plus, yeah, so plus 3x, that's fine. Then I've got minus 1, so I've got minus 1, let's put minus 1, and that's going to be equal to minus 11. Okay, let's add everything to the other side, so 0, we've got x squared minus, what have we got? Minus 3x, and then we're going to have now, what's that going to be? Minus 10. And that's going to conveniently factor. Let's go ahead and factor that. We're going to have x minus 5, and then we're going to have x plus 2. That works. Okay, so I've gone ahead and factored that, so we can see from this right here that x will be equal to positive 5, or x will be equal to minus 2. So they now are our two values of x, and we can just sub it back into the linear. Either one. These are identical. Don't whatever you do, sub it back into that. That's a mess. So what we can say then is now, and I'll write it just here. Of course, when you're doing this in your work, make sure you're nice and neat with it. When x is equal to 5, we can say now 2 lots of 5 plus 1 plus y is equal to 1. So what's that going to give us? Y is going to be equal to minus 9. So y is going to be equal to minus 9. So we've got the point on this particular graph of 5 comma minus 9. That's just giving the coordinates. We're not asked for the coordinates, we just need to solve it. And then we can say now when x is equal to, let's do minus 2, just subbing it back in, 2 lots now of minus 2, plus y is equal to 1, so that's going to give me y is equal to 5. Y is going to be equal to, what do we have, 5. So we've got now the point minus 2 comma 5. So that's solved, and again we would just check those through, just go ahead and make sure that it satisfies that one. I'll let you hit pause and do check that they satisfy both. It's not a case of just satisfying one, we need to ensure they satisfy both. So that's quite a nasty an example of a non-linear and linear simultaneous equation. Okay, let's finish with something a bit tougher, and then in the next video I'll do some exam style questions. Let's go for one now. We would be asked to prove that, so let's write this down, prove that y is equal to 2x plus, let's go for 2x plus 5 over 4 touches, and this is a key word, touches, now the curve, so let's go for curve, and we'll go for y squared is equal to 10x. Okay, at the moment, quite clearly, knowing what that looks like is possibly not as straightforward as you like. This is a quadratic, but we got y squared is equal to 10x. This is a parabola, but it's on its side. What we're going to have is something looking like this. And what we're being asked to do now is show that this line touches. Now 2x plus 5 over 4, that shouldn't be too hard to get your head around and think about what it's going to look like. It'll be a straight line, gradient of 2, y-intercept of 5 over 4. So that's going to look something like that. So what we want to do is show now that we got one point of intersection. The first thing I'm going to do now is the following. I'm going to write now here, if touching, so if touching, from our work with the discriminant, we can say b squared minus 4ac will be equal to 0. What we're going to have here is a repeated root. So repeated root, let's just do that. And this is quite a tricky example. So what we're going to do then is the following. We're going to set these equal. I'm going to take the discriminant and show that it equals 0. So let's go ahead, let's write this. So we've got equation 1. Y is equal to 2x plus 5 over 4. Equation 2, I write equation 2. We've got y squared is equal to 10x. Therefore, what I'm going to do is rewrite now equation 2 as 2x plus 5 over 4 squared is equal to 10x. Now, all I've done, this is y right here, so I've taken my expression for y in terms of x and put it here. So I've written, if y is equal to 2x plus 5 over 4, then y squared is going to be this quantity right here. So let's go ahead and expand these brackets. We're going to have 4x squared, then we're going to have plus 5 over 2x, plus another 5 over 2x, plus, and then if I square this, I'm going to have, what's that going to be, 25 over 16. And that's going to be equal now to, let's put that in, that's going to be equal to 10x. So let's go ahead and write that in. So let's rearrange this. 5 over 2x plus 5 over 2x is 5x. So we've got 4x squared plus 5x minus 10x, which is going to be minus 5x. plus 25 over 16 will be equal to 0. So our value of A using the discriminant will be 4, our value of B is going to be minus 5, and our value of C is going to be 25/16. So using the discriminant, we can state B squared minus 4AC will be equal to 0 if touching. Remember, this goes back to our idea of when we looked at the discriminant. When we have the discriminant, we have 3 different scenarios, and I'll draw these as quadratics. Obviously, in this particular case, it's slightly different. Let's go ahead and do this. So what we had with the discriminant, if we had now B squared minus 4AC, so this was when B squared minus 4AC, so B squared minus 4AC was greater than 0. We had 2 distinct real roots. So 2 real distinct roots. So 2 real roots. If we had now B squared minus 4AC was equal to 0, we had a repeated root. So this was B squared minus 4AC equal to 0. We had now a repeated root. And this is what we're looking at here. We're looking at this repeated root because it's going to touch, or if you like here, we've got now the x-axis as a tangent. And then the other case was when we had B squared minus 4AC, B squared minus 4AC was less than 0. We had no real roots. And if you haven't seen that video, please do check that out. So let's go ahead and do it with this one right here. So we've got B squared, which is going to be minus 5, and we need to square that, minus 4A, which is going to give me 4 lots of 4, and then we're going to have C, which is 25 over 16. So we've got 25, and then we've got minus 16 lots of 25 over 16. They're going to cancel, so we've got 25 minus 25, which is equal to 0. Therefore, we can say now, therefore, discriminant is 0, therefore, touching. Okay, so that's a nice example of how we could use simultaneous equation, rearrange, use our other knowledge from the discriminant, and go ahead and deal with quite a tricky problem. So there we go. That hopefully should be enough revision and potentially new learning on simultaneous equations to see you through the majority of things that you are going to come up against. Throughout your studies, you're never going to move away from simultaneous equations. They're always going to be around, and you need to be able to manipulate them right the way through. So it's not a discrete topic as such. It's not a standalone topic that you can be bad at and think, well, I'm never really going to use it. For example, like sequences. Sequences, some people just dislike, and they can kind of think to themselves, I don't have to be brilliant at that because it's not always going to come back and bite me in the butt. This will, so do get used to the different situations.